This is the video for the used car routines. Routine starts over here on the left and ends over here on the right. First it sets I to the add level and then sets the start value to the add level at that offset of I. In our example, that is I is 4, and that's the add level. Next, it sets small to 1 and divides its floating point, small, by 100,000. Then it fills the 400 values at matrix with 0. So it's going to start out as a null matrix. Then it sets the matrix size to 20. Our matrix is going to be a transition matrix 20 by 20. Then it sets factor to 90 and divides its floating point by 100. That means it's going to be 0.9. Then it sets the matrix value to very first position to 1. And over here that matrix is, and there the first position is 1. That means whenever it gets in row 1, it's going to stay in row 1. Next it says set U to the start value, divide it as floating point by 100,000, set V to the start value and divide it floating point wise by 100,000. Then it says for I of 20, and down here we have next I to 399, 21 at a time. It's going to go around this loop, I believe, 19 times. What it's going to do is it's going to put these values in here, this 0.0420, the 0.0840, and so forth. It's adding 21 each time. 20 would put it just at the beginning of the next row. 21 moves it over 1. So we're not putting these on the diagonal. Here's the diagonal. But the one just to the left, the diagonal. So over here we're going to start out by setting matrix at offset I with V. That's this first one. Then we set W to 1 and we subtract from it that value and we put that value, W, into matrix at 1 past I. Well, that is the diagonal. So it first says, well, this value is 1, but the row has to add up to 1, so we subtract this value over here from it. So now the value of the row sums to 1. Then we add U to V because we're going to say we're going to another row and we're going to add the probability for selling a car. But we're going to multiply that by our factor of 0.9. That's because, yes, we have more cars, but that doesn't mean we actually doubled the number of cars we're going to sell. We're going to say, nope, there's the diminishing returns on it. Alright, so it multiplies it by 0.9. So it's going to go around there the other 19 times to fill up all the other rows. Always putting a value, 1 to the left of diagonal, and then subtracting that from 1 to give the number on the diagonal. Alright, when that is over, then it sets LS to 20. That's the offset jump it's to make if it uses a mul L, that multiply list instruction. Wants to know how much to jump to change each row. That's 20. Then it wants to know how many rows there are. Well, there's 20, but it added 1,000 to it to tell it that it's going to be a matrix operation it's to perform. Therefore, it's going to be 20 by 20. Then it moves the 400 values at matrix to matrix work. And then it starts a loop for I of 1 And over on this side here, it says next I to 4, one at a time. It's going to go around this loop 4 times. Well, first thing it does is it says I'm going to multiply matrix work by matrix work to give matrix power. Well, matrix work starts out being our matrix that we made, this here. So it's saying it's multiplying it by itself, and then it takes that answer, matrix power is the answer, and stores it in matrix work. So the next time it comes around, this matrix work is going to be what the answer was the previous time in matrix power. Alright, then it says branch if equal I to 1. Well, that's the first time it goes around. It's going to go to AC right to the next I and not do anything else. It's just going to go there and come back to the beginning again. Well, then it's going to do the raising of the power again. It's going to take matrix work, which was the previous matrix power, multiply it out, and then store it again in matrix work. But the next time it goes around, I is going to be 2. Well, here it says if it's not equal to 2, go to AB. Well, the next time around it will be equal to 2, so it's going to come down here, and it's going to move the matrix at matrix power to matrix end. So now matrix N is going to miss the first multiple, and we'll explain why once we get done. It's starting now when it's at the power of 4. First time it went around, it squared it. This time it has the 4th power and put that in matrix end. Then it goes to AC. That's the end of that time. Well, the next time's around, it's not going to be 1 or 2. It's going to go here to this instruction, which says multiply, well, first move matrix end to matrix temp, and then multiply it by the matrix power to get matrix end. The reason that it skipped the first time around is we want it to be at the 28th power. Well, if we kept going around here, it would get to the 32nd power. We want the 28th power, so we have to eliminate one of them. So that's what this is doing. It's starting our matrix end, which is this one down here. It's going to do this one less time, so that it gets to the 28th power instead of the 32nd power. Well, so here's when all the rest of the times it goes around, it is going to multiply matrix N and double it, square it each time, and then it ends up going around. Now, this is the original transition matrix that we were finding over here. Here is the one where it's to the 28th power. Now it's telling us if we started out with 8 cars, the probability that we still have 8 cars is 0.002. The probability that we sold only 1 car is 0.0032, and so forth. 2 cars, 0.0212. Sell 3 cars, 0.0804, and so forth. It seems like the most likely thing down here is that we sell 6 or 5 cars. 0.2609 that we sell 6 cars. 0.2838 that we sell 5 cars. And here we can see the probability that we sell all 8 cars is 0.0274. So we decided to replace at 8 cars. We start out our 28 days with 8 cars. That's why it's highlighted in the white here. These probabilities were determined by the amount of advertising we did. Up here was the ad level. We raised it to the 28th power. That's what it was doing up here. And this is what the answers are. we know how many cars we're going to sell, given that we started with 8 cars. Alright, this is the end of the video for the used car routines.